Our little astronauts of Standard 3 enjoyed all the aspects of the virtual field trip. An inspiring video on Kalpana Chawla encouraged our students to aim high and bring great honor to our country, India. Our young boscoites have voiced their views on their favorite planet. It was an amazing and fun filled learning experience.
Welcome to our solar system. Below you will find our sun. Our star is 2 octillion tons of hot hydrogen gas emitting 400 septillion joules of energy every second. The hottest part of the sun is its 15 million degrees Celsius core, where it's been fusing hydrogen into helium for the past 4.6 billion years. Despite that, it's only considered a middle-aged star. Now let's check out the closest planet to our sun, Mercury. Orbiting the sun in just 88 days, Mercury also has the most elliptical orbit of any planet. It spins very slowly, once every 2/3 of its orbital period. Despite its surface reaching a blistering 430 degrees Celsius, it still has water ice in permanently shadowed craters near its poles, where the temperatures stay below minus 170 degrees Celsius. The next planet in our solar system is Venus. It's the planet with the hottest surface temperature. At 460 degrees Celsius, it's hot enough to melt lead. Its air is almost entirely composed of carbon dioxide, with a thick layer of sulfuric acid clouds. Its rotational axis is flipped upside down, which means that the planet spins backwards. The third and best understood planet is Earth. Our home planet has a dense metal core, a thick viscous rock mantle, and a thin crust. It's unique in the solar system for having humans and permanent liquid water on its surface. Other planets may get the former soon. At 3,470 kilometers in diameter, our moon has the largest moon-to-planet size ratio. It's thought to have formed when a small planet impacted Earth at a grazing angle billions of years ago. It's heavily cratered and has huge floodplains on it called maria. Next up on our system is Mars. Its iconic red color comes from its rusty rocks and dust. In the past, Mars was once very wet, with oceans, a thick atmosphere, and a warmer climate. But its lack of magnetic field meant no protection from the solar wind, which eroded its atmosphere away. Between Mars and Jupiter is a large asteroid belt. It's a ring-shaped region containing rubble left over from the formation of the planets. Past the asteroid belt, we find our system's Jovian planets, starting with Jupiter. A gas giant, it's the largest planet in our solar system. It has a dynamic atmosphere, including belts, zones, and a gigantic red spot created by a persistent hurricane. The Great Red Spot is a persistent anticyclonic storm. The spot is large enough to contain 3 Earth-sized planets. It's still unclear what exactly gives the spot its red color. The next planet in our system is Saturn. It's a gas giant with a broad set of rings. It has a hexagonal cloud pattern on its north pole. It's the least dense of all the planets, even less dense than water. Made up of ice particles, Saturn's rings are 250,000 kilometers across, but only 10 meters thick. Gaps in the rings are created by the gravitational tugging of the moons orbiting Saturn. Uranus is an ice giant with a small rocky core and a thick mantle of ammonia, water, and methane. It also has 13 distinct rings. Uranus has a huge tilt, 98 degrees with respect to its orbit. A massive glancing collision long ago is one hypothesis to explain the extreme tilt. Technically considered the last planet in our solar system, Neptune is an ice giant with a similar composition to Uranus. It's the most dense of the outer planets, and the only planet found by mathematical prediction rather than by empirical observation. At the outer edges of our solar system, we find the Kuiper Belt, filled with smaller, rocky and icy bodies. Pluto is in this region. It was originally discovered in 1930 and categorized as a planet, but it was recategorized as a minor planet in 2006. And there you go, a crash course on our solar system. Even though we've explored a lot of it, there's still a huge amount left to discover, and that's the beauty of science. There's always more to learn. Thank you so much for watching. This video was created by the
Kalpana Chawla. Kalpana Chawla was born in Karnal, a small town in Punjab, and she was really lucky to be born there, for Karnal was one of the few towns in India which had a flying club. She and her brother Sanjay used to follow the small, slow-moving pushpak airplanes on their bicycles, just to figure out where these airplanes were headed. Very often, both of them used to fall and hurt themselves because they were looking up at the planes instead of the road while cycling. They would often pester their dad to take them flying, and finally one day he relented. Both the children took turns riding in the pushpak as well as a glider that the flying club had. I think that's really my closest link to aerospace engineering that I can dig deep down and find out there, she said in one of her interviews. When she was 11, her imagination was further ignited by the glamorous photographs of the Viking landers' Mars mission in the Illustrated Weekly of India. Her father knew J.R.D. Tata, a pioneering Indian pilot and industrialist, quite well. He was also partly instrumental in inculcating her interest in flying. In another interview, she said, "Also growing up, we knew of this person, J.R.D. Tata, who had done some of the first mail flights in India. And also the airplane that he flew for the mail flights now hangs in one of the aerodromes out there that I had a chance to see. Seeing this airplane and just knowing what this person had done during those years was very intriguing and definitely captivated my imagination." The combination of these experiences fueled her desire to become an airplane engineer when she was just a child. At that time, the education system in India was such that one had to decide during class 8 itself what stream one wanted to take. So she chose to study physics, chemistry, and mathematics because, as she rightly said, "I'm going to do aerospace engineering." Kalpana passed out from Tagore School, Karnal in 1976. She obtained her aeronautical engineering degree from Punjab Engineering College in Chandigarh in 1982. In her first year in college, whenever anyone asked her what she wanted to do, she'd say, "I want to be a flight engineer." But I am quite sure at that time, I didn't really have a good idea of what a flight engineer did. Because flight engineers do not do aircraft design, which was an area I wanted to pursue and did pursue in my career. And it's a sort of nice coincidence that that's what I am doing on this flight, she said just before boarding Columbia in January 2003. Soon after passing out from Punjab Engineering College, she moved to the United States to obtain a Master of Science degree in aerospace engineering. She was successfully awarded the degree by the University of Texas in 1984. She got her second Master of Science degree in mechanical engineering 2 years later, in 1986. Finally, she did her PhD in aerospace engineering in 1988 from the University of Colorado. Later that year, she took up a job at NASA Ames Research Center. Kalpana held a certificated flight instructor's license for airplanes and gliders, as well as commercial pilot's licenses for single and multi-engine airplanes, seaplanes, and gliders. Soon after reaching the US, Kalpana married John Pierre Harrison in 1983. and was granted a US citizenship in 1990. She travelled to India in the winter of 1991 with her husband and spent time with her family in Karnal. That was the last time she set foot in India. After she became an astronaut, she hardly had time for anything else. In 1993, she joined Overset Methods Inc., California, as Vice President and Research Scientist. Here, she led a team of researchers who were responsible for developing and implementing efficient techniques to perform aerodynamic optimization. In March 1995, Kalpana Chawla joined the NASA Astronaut Corps and got selected for her first flight in 1996. After undergoing rigorous training, she went on her first space mission in November 1997. She was a part of the 6-member crew that flew the Space Shuttle Columbia Flight STS-87. She was assigned the duty of a mission specialist and prime robotic arm operator. The purpose of STS-87 was to focus on experiments designed to study how the weightless environment of space affected various physical processes, as well as to observe the Sun's outer atmospheric layers. In her first mission, Kalpana Chawla travelled over 6.5 million miles in 252 orbits of the Earth, logging 376 hours and 34 minutes in space. An hour and a half to travel around the Earth once. My goodness, how small this planet really is, said Kalpana Chawla, recalling her emotions during her flight into space. Kalpana was the first Indian-born woman and the second person of Indian origin to fly in space. Rakesh Sharma had flown in a Soviet aircraft in 1984. While Rakesh Sharma represented India, Kalpana Chawla represented the US, being a US citizen. They both had never met. In 2000, she was selected for her second flight as part of the 7-member crew of STS-107. This mission seemed to be jinxed right from the beginning. There were repeated delays caused due to scheduling conflicts and technical faults. On January 16, 2003, Kalpana Chawla finally returned to space aboard the ill-fated Space Shuttle Columbia on mission STS-107. As millions waited with bated breath for the Space Shuttle Columbia's return, it just disintegrated while re-entering the Earth's atmosphere. It was watched by aghast people all over the world. Kalpana Chawla died a heroic death. Her brother Sanjay Chawla remarked, "To me, my sister is not dead. She is immortal. Isn't that what a star is? She is a permanent star in the sky. She will always be up there where she belongs." Kalpana Chawla has been posthumously awarded the NASA Space Flight Medal, the NASA Distinguished Service Medal,
the Defense Distinguished Service Medal.
Our solar system belongs to the Milky Way galaxy. The Sun is the center of our solar system. Earth is the third closest planet to our Sun and takes 365 days to orbit the Sun. I love Earth. It is full of life chirp, and humans go about to fulfill their daily needs. The sun gives light during the day while the moon, Earth's only satellite, shines in the night. We love the Earth. It is our home.
What an amazing virtual space trip that was! Hi friends, I'm Ashman Sawadekar from 3rd P, Don Bosco High School, and my favorite planet is Saturn. It is the second largest planet of our solar system. According to 2020 reports, it has 82 moons. Wouldn't it be interesting to visit the space in real?
My name is Montes Fernando. I am studying in class 3rd B. Today I am going to speak about my favorite planet, Venus. Venus is the second planet from the Sun. It is named after the Roman goddess of love and beauty. It is the second brightest natural object in Earth's night sky after the Moon. First successful landing on Venus was Venera 7 on December 15, 1970. Venus is called Earth's twin sister because of their similar size. A day on Venus is longer than a year. Venus is a unique planet because it spins the opposite directions of Earth. You can see Venus without a telescope. Thank you.
Hi, my name is Richard Sonai. Do you know which planet is this? It is my favorite planet, our Mother Earth. It is the only planet that supports life in the entire solar system. It is 4.5 billion years old. We must always protect our Mother Earth.
My name is Mitanj from class 3rd. Among 8 planets, Saturn is one of my favorite. It is very interesting planet. It is 6th planet in the solar system. It is very famous for its stunning array of rings. It is very easy planet to pick out because it is one of the brightest light in the sky.
Mars is the 4th planet from the Sun. It is called the red planet. Astronauts have found water on Mars. Hence, there is a possibility of life on Mars. I dream of being on Mars because there is life on it.
There are 8 planets in the solar system. My favorite planet is the Earth. It is the only planet that supports life.